think you'll find that some of the practices you've been using might be less than perfect. We'll discuss this. Back in the 1950s through the mid-80s, you could do anything, literally anything on a circuit board. We violated every law of physics in existence back then. The only one we didn't violate was two things occupying the same space at the same time. Other than that, everything we did was wrong and they worked anyway. It was just the way it was back then. Why is that true? Because everything in those days was low frequency compared to today. Circuits we put on PC boards are a lumped length at low frequencies, and they're a distributed length at high frequencies. When something is a lumped length, you can pretty much handle it any way you feel like. A good example, even in RF circuits today, I've done a lot of RF design over the years. When you're dealing with 1 and 2 gigahertz designs, traces you have that are shorter than 3/16 of an inch, a quarter inch or so on, they don't have to be controlled. They don't have to be controlled impedance. You don't have to worry about, you have to reference them to a plane, but you really don't have to worry about all the things that people think you do. And a lot of the RF engineers I've known will tell you, oh, that's not true. Every trace, no, that's not true. And I've proven it repeatedly to many RF engineers. But things that are a distributed length, you need to pay attention to. When is something a distributed length? I actually have a table in my lengthy presentations that I give people to show them exactly how long a trace can be based on frequency before you have to pay attention to its characteristics.